Welcome. This question says a sample of gas has a pressure of 4 Pascal and a volume of 7 meters cubed at 7 cubic meters at 420 Kelvin. How many gas molecules does it contain? So let's visualize it as our sample. And we know that the pressure is equal to 4 Pascal. And we know the volume is equal to 7 cubic meters. And we know the temperature of it is 420 Kelvin. And so I need a relationship that will link that to the number of gas molecules. And there's the equation that comes to mind is PV is equal to big N KB times T. And this is similar to another equation you might be familiar with which is PV equals little n RT. And so we've got to be a bit careful here. Big N is the number of gas molecules, and little n is the number of moles of gas molecules. Moles is a term like a dozen or a score. It's code. It means Avogadro's number of gas molecules. It's a huge number. So you've got to be careful. Are you talking about moles or are you talking about molecules? Moles of molecules or molecules? And when people tend to write down MOL, it could be either one. So this is an area where I try to take my time and write out exactly what I mean. In this case, I want the number of gas molecules, and so I'm dealing with this expression. So I can say, okay, well, just rearrange. The number of gas molecules is equal to PV over KB, that's Boltzmann's constant, times the temperature in Kelvin. If I look down here, that's going to be 4, that's going to be 7, and what is KB? In my class, I don't expect people to learn these things. It's 1.4 times 10 to the minus 23. I'll give you it in a question, or I'll give you it somewhere on the exam paper. And then the temperature, I gave you it in Kelvin, so it was 420. So the number of gas molecules is equal to, so let's make sure I get my calculation right. It's 4 times 7, enter. And then I'm going to divide that by 1.4 second EE to the minus 23. Enter, divided by 420, enter. So I'm getting 4.8 times 10 to the 21 molecules. And that's my answer. Let's talk just a little bit about calculator use here. I see common mistakes where people try to do this in one step without ever pressing the enter key until they get to the very end. And people end up not using enough brackets, and so they end up, saying 4 times 7 divided by 1.4 times 10 to the minus 23. And then they say times 420, and it's a mistake. So what I've learned the hard way is I learned to do it in bits. 4 times 7, enter, divided by 1.4. I like the EE function, second EE minus 23, rather than times 10 to the caret minus 23. It's just much simpler. And then enter, and then divided by 420. you know, we're going to be physicists or engineers or you know, other forms of physical science people. We're expected to get the right answer. And knowing how to use your calculator on a problem like this so you can get the correct numerical value is important. And so if you don't, expect to lose points on that if you're in my class. And there we have it.